Okay, so appreciate you all coming tonight. The topic, Beyond Code Coverage, Understanding the Ripple of Change. This came out of our own need. We found that code coverage in and of itself wasn't enough. And so what we want to talk about today is the impact of, change impact, how that affects, how you do testing, and, what Coverity had to go through to solve that problem or attempt to solve that problem in the most efficient way. So what we think the problem is, and then possible solutions to that problem, right? And so without further delay, really quick question. How many people are doing automated code testing on your code today in any way, shape, or form? All right, great. Almost everyone does it in some automated way. If you had to choose, if you knew, and this includes any type of testing where you're perhaps doing code coverage, what percentage of your code would be tested? How many are at absolute 100%? Yeah, we're not either. 76 to 99. There might be a few. How about 50 to 75? Okay, we're getting better. 25 to 49. Okay, another quarter. 25% or less, or you don't know. Right, okay.
Some people admitted that is great, thank you.
Right. The camera's not on them, right? We're all good, right? So, okay. It's a hard problem. So what's wrong with code coverage in general? One of the problems that we have is that you have the kind of a law of diminishing returns. The rule of thumb that we hear when we talk with our customers is, man, if I can get 60, 70, if I get 80%, I'm golden. I'm doing really well. The problem is, not all code is testable, or it's more difficult to test. Some of it's completely unreachable, perhaps. Maybe it's dead code, or it's just conditions that you can't simulate easily. The other problem is that not all tests are equal, right? I can test a setter and a getter, and that doesn't give me as much value as testing a piece of core functionality that is probably a little bit harder to set up and test. So just because I get to 50%, if I tested all my setters and getters and my logging APIs and something is really easy, I might be at 50%, but I may be missing the latest code or the code that's actually most important to me, the highest risk code. So how do you deal with that? And so most people just get as high a percentage as they can, and you know what? And that's the coverage tool kind of the day. Now there are some of the tools out there that are there. They have some way of filtering, but it's a lot of manual effort. And it's not as easily automatable. If you look at a study from Capers-Jones, this is how many people are familiar with Capers-Jones and some of the things he's done, right? So this is an ongoing study that he puts out about once a year, and he studied, this is from 2012, he studied 600 some companies, 13,000 code bases, and over a 28-year period. So the data is, I find interesting. Anybody that studies testing for that long, there's probably some good nuggets in there. And this is one of the slides I like the best, particularly in the unit test and regression test area. But if you look at any given column, and you could argue what order that you might do testing, any given column, there is no 100%, right? Even in the best of the best, even in, say, code inspection and static analysis together, which he doesn't split out, by the way, you can get maybe up to 90% of your code if you're diligent, but there is no 100%. So picking and choosing, and not everybody I have yet, there's maybe one government customer I have that builds missiles that does all of these, but very few people do. You have a limited amount of resources, and so that's yet another problem. So typically you can get, and if you look at the numbers here, they're cumulative, so I can remove that percentage at each given level. So at requirements and design, I can remove, in the median column, 30% of the defects I have at that moment. And then the next one, I can remove 40% of what's left, and so on down the line. If you did best of the best, you would get to 99.7% of defect removal. So the point here being is that even with standard code coverage and good testing, you may fall short of what you can achieve fully with unit testing. So, you have time pressure. How many people here love writing tests? Wow, no. Oh, one person does. Okay. If you're a hardcore test-driven development guy, you write the test first, then you write the code, right, to make it pass. So, there's most of the time you have a resistance in your development organizations to write tests. I don't have time. I'm busy writing code. I don't have time to test that code. Most people do want to test their code. I haven't met a developer who says, I'm going to write some bad code today and have it fail in the field. Nobody wants that. But it's the last thing you kind of want to do is I comment in your code. Do I comment in my code? Yeah. If I do it as I go, it's great. If I wait till the end, I'm in trouble. The process can be inconsistent. Some people test one way, some the other. We found that as we've moved from a lot of manual testing to more automated testing, that testing almost becomes, there's a design in it. There's almost an art to it, right? To test properly and to test well as you're writing code, you almost have to design it in. And so we've found internally in our own development organizations that we've almost taken pride in the fact that we write good tests. And it took time to get to that because we were, just like everybody else 2-3 years ago, testing, we're going to throw it over the wall, do some manual testing. We'll get to that in a moment. And then the visibility and control over what to test first is typically not there. And so just very briefly, who Coverity is, we're a small company of about 350 employees, and we've been around for 10 years. And we started off with a professor and 5 PhD students in a room writing code, the classic Silicon Valley kind of story. We've grown up to be a small company, and we've actually recently been acquired by a company called Synopsys. Who's ever heard of Synopsys? Okay. It's probably the 16th largest software company in the world that most people never heard of. They specialize in software design for creating chips. And they dominate in that market. And what they've done with Coverity is purchased us to create a software division in the commercial, non-embedded kind of markets, and we're the cornerstone of that development. So it's very exciting. It's a $2 billion company with $1 billion of cash in the bank. It's all online. We're a public company, and it's a time for growth and expansion in our company. So it's very exciting. Some of the key things that we have done, though, is we've traditionally been known for static analysis, and what we've done is we've taken these engines and the data we've provided and expanded into other areas of what we're calling code intelligence. So I don't want to get into too much of the marketing, but some of that intelligence is taking, the data and allowing you to make decisions better on testing. And so at the end of the day, we help you write software better, faster, right? So let's talk about code coverage now. Our general release process internally is a 6-month release cycle. We do a 3-month release planning. There's 6 months of hardening, and then we release. And all of our internal names are after cities in California. So Alameda, Berkeley. I think we're on. I want to say there's some innocuous name. What's the next one? G, but I don't remember the name of it. But anyway, it's fairly boring. But Fresno was our latest release. If we look at how that works, typically there's previous release execution and planning, release execution, and then, of course, there's an overlap. We're an agile style process. I love the term I heard just a couple of weeks ago. I think, Ed, you were on the call, but Scrumafall, right? So we have definite release milestones. We went from waterfall to agile, but we do a lot of agile in between, a lot of different milestones, and we release twice a year. So we have daily stand-up, we have 2-week sprints, we use Bugzilla, and we are Coverity clean when we release our code. And in fact, we use all of our own technology on our code every day. So we eat our own dog food, which is a good thing. So where were we 2 years ago? From a testing standpoint, we have basically three pieces to our product. There's a front end that compiles the code. There's an analysis piece that does the different types of analyses, whether it's static analysis or testing or whatnot, and then or security. And then we have our Coverity Connect, which is our GUI interface. And so 2 years ago, we did a lot of automated testing on a lot of the engines that we have. That was fairly straightforward, but almost all of the testing that we ran on our GUI product was manual. It would take probably, let me see, I know it says so, end-to-end testing was done manually, and we'll focus on the last two, where the Coverity Connect and the manual testing, which is the most interesting piece because it gets into the topic of coverage and how much trouble we had previously. And so what we would do is we had an outsource in Europe. We had the traditional, the typical problems when you outsource. We had language barriers, a 10-hour time difference. We had a lot of QA skills, but not a lot of development skills. How many people understand what this is like, perhaps? All right, so it's a very common occurrence. So we had a 6-week hardening cycle that did a lot of end-to-end testing, and as you could imagine, the churn, something happens, and now a release comes back. We have these differences, and it was like Russian roulette. So we wasted a lot of QA cycles just to find trivial bugs, and a lot of times we wouldn't get to the critical parts of the code in the time frame we had, and then you were in a keep the lights on situation, ordering in pizza and fresh clothes while we fixed and get the release out on time. So. And that was a joke, by the way, a bad one. But anyway, you understand the point. A lot of stress, a lot of pressure just to get the releases out in good quality. Reasonably successful, but when you're a software quality, security and testing kind of company, and any bug makes you look bad, right? Didn't you run Coverity on Coverity? I don't know how many times I'd like to just go after somebody. What do you? Yes, we do, but we have the same problems you do when we write software, right? So the first thing we tried to do was, let's break down the boundaries between development and QA. Let's interleave development and testing. We'll do a reorganization, right? So why not? So 2/3 of our QA resources were pulled into development. The goal was test as you develop, and through test automation, and the results, well, they weren't as successful as we might expect. The QA team was not trained in programming. There was little actual progress in the test automation, and the time difference in language barrier still was a big barrier. It was a big problem. So we had to do something a bit more drastic. So what we did was, first of all, we eliminated the time difference. We opened our own facility in Calgary, Canada. And there was no language barrier. You're a 2.5-hour flight from our San Francisco office, which is where most of our development is. And we started focusing a focused interview process where we transitioned over a 12-month period. We stayed budget neutral in some sense as we transitioned slowly over that time period. And we hired programmers focused on test automation. Sounds like something similar that you're doing as well that you mentioned earlier. So they were highly motivated to automate the test because basically we told them, you're a tester until you automate, and once it's automated, we can move you to other things. So it was a good combination. They came on board knowing what the job was, and in over a 2-year period, we made some rapid progress. And so, and of course, you had a growth path from somebody who came in writing tests to somebody who was going to move eventually into the development organization. So we focused this automation effort because most of our other processes that weren't part of the GUI part were already automated. So we focused automating as many tests as possible, specifically for the Coverity Connect and the end-to-end testing. The automated test served basically two purposes. We want to encapsulate the behavior in the test. There are products out there that can say, we can auto-generate tests for you. That's great, but it's going to auto-generate for you on the code as it is, and that may not be correct behavior. So I always I like that question because it sounds great when you first hear it. Let's auto-generate a bunch of tests on the existing code. If the existing code is absolutely correct, which you may not be completely sure of that, then you have a problem where you have now a bunch of tests that test the incorrect behavior. So it's a double-edged sword there. Once the tests pass, you can be declared as complete, and you have a negotiation between test and implementation. So we put those two very closely together to make sure that now, as we were writing these tests, that the implementation and the definition of complete absolutely matched. And that gave us the highest quality. And what that gave us was a basis for the set of tests that we run automation on. Now, of course, it's exactly how you'd expect it to work or how you'd want it to work. You write the automated tests, you put them into a repository, now they become your regression set of tests. As you make changes, if those tests fail, you know that they were correct in the first place because you guaranteed that, and you have more or less guardrails. It's exactly how when you preach testing and automated testing, this is exactly what you want, and this is exactly what we saw. But we had to have that tight connection between development and testing at the same time. And not all tests can be developed in lockstep. One of the other things that we found out, you have to really, design to have your functionality and your testing together. And if there are cases where you have multiple sprints to get to a functionality where you can finally test, test a unit. A unit may not always be just a class or a set of functions. So we found that some of the more complicated features required, that you had to do a little bit more development prior to doing testing. It's not quite the test-driven development case, but we just found that those areas were there. So as a result, over a 2-year period, you can see from the yellow is the manual testing and where we started, and the green is the automated testing. So over a period of a few years, let me see if right, that shows it a little better. So over the course of the testing that we've done, in terms of person days, the manual testing effort has decreased. We still have a significant amount of manual testing on the GUI itself, but the end-to-end testing has significantly decreased. We still have this focus on our product, but it took us 2 years to do this. Again, we remain budget neutral in the process, which is key. We didn't want to overspend just to test code, but at the same time, we've made a significant improvement in the manual testing. Now, what does that lead to ultimately? Oh, I'm ahead of myself. Sorry. So, from a technology standpoint, most of the tests are short and are run as part of the build. So now we can automate as part of the build process.
I think it means expand and not extended.
Yeah, I was about to say that. I just wanted to make sure I wasn't. I've looked at this slide, for a week now. Expanded system. Right. So we took the automated tests. We keep them short. We make sure that we can expand the automated tests and reporting, and a heavy investment in server automation allows us to now work on automating the provision. Sorry, I lost my train of thought. So we put a heavy amount of investment in the amount of hardware that we had throwing at this. The ultimate was we had this 6-week hardening cycle. The ultimate goal here was to throw enough hardware and resources and automation at this to shrink that down as much as possible. And that's the point that I'm trying to get at here. And so, like I said, we use our product on our product on a daily basis. We are Coverity clean at our release. And you can see that just the number of defects that we address prior to release for our Quality and Security Advisor products is quite significant throughout a development cycle. So, in the process of doing this, we found that we needed some additional way of focusing coverage on testing. And this is what I think you'll find most interesting. When we talked about code coverage earlier, code coverage is at best, a weak indicator. It is a good indicator, at least it shows that you can measure it, but we needed a better way. How do you make sure that your new features are being tested, especially if you're at, say, 60%, you add some new features and you maybe get to 70%. Well, did that code that you tested, that extra 10%, did that cover everything that you expected it to do, and without a manual effort and a significant amount of digging through code and log files, can you tell that? And is it, in the absence of measurable criteria, this leads to, testing as it doesn't drive the correct behavior all the time. So, oops, backwards. Oops. So, we needed a tool that could identify new code, identify and exclude code that we didn't care about, and workflow that automatically notified developers on a per file and per function basis. Okay, so and that ended up being key. Also, providing management with the visibility to guide your testing. How many people have? Not many people in the room probably have unlimited testing resources, and you have a specific testing budget. And so what we found was we were running into this problem where, the resources that we required for testing were limited, and when if we didn't monitor it properly, what would happen is that at the end you would have still a firefight, even in the automation case, where you realize that you didn't get to the most critical part of the code, or where the perhaps errors from impact were occurring, and right at the end you have a massive problem, and then you have a lot of issues. So having the ability to, one, focus the team and manage from a proper visibility was key. And so how does that work? Well, code coverage is fairly basic. I add some new code. Did I test it enough? I can use source control management to do that. I can just use basic code coverage in log files. That's easy enough. A very subtle issue that we have found is that I touched this part of code, but there's a whole part of code I didn't touch, and did I impacted based on my changes? And when I do that, one of the worst things that can happen is code gets out into the field or even into your testing environment, and you realize that there's a bug in this part of the code, and lo and behold, you go back to the development team and they say, there's no way that we affected that part of code with the changes we made. And after a significant amount of digging and scratching heads and realizing that, yes, there was some weird indirect code construct that happened to cause an impact over here. So we, at Coverity, for 10 years have had in the product this impact analysis, and we were using it to do our code analysis based on change. This part of the code changed, this part of the code was impacted, so only analyze that part, and we've reduced our analysis cycles that way. What we found was, as we started realizing we had the same problem when we were trying to automate our testing, was that wouldn't it be great to expose that information to our dev and testing teams to show that, okay, yes, you have to test this new code, that's obvious. But guys, you touch these files and functions and classes, you lit up 25% of the code base by doing that. Over here on code you didn't touch, we got to look at testing that properly too, or testing that first as we move forward, right? And so that gave us a way to direct our teams, right? It's one thing to say, I'm going to do a full test cycle on this release. It's another to say, okay, I'm going to do that, but I'm going to focus on the new tests, of course, but if I have to prioritize what I do first, I'm going to focus on the code that's changed and the code has been impacted by those changes first, so that my highest risk code is going to be tested first. And so by pulling that data out, we basically invented a new product by something we needed internally to do what we needed to do. I've challenged everybody I talked to for over a year and a half. I really know of no other tool that freeware or otherwise, that can do this type of analysis. So I'd love to know, because I don't think there is another tool that does that depth based on code construct on how we do this. So what can you do at that point? Where are the sweet spots when you test code? You can now, instead of saying it's tested or untested, you can say, okay, I've modified it. So what you can do, let's look at the source control management dates. let's look at, so I can now have a dividing line. Was it modified or not modified? So I can pick a date, say March 1st, from my last sprint till today. And let's call that March 1st. Let's say everything before March 1st is going to be legacy. Everything after that is going to be modified. So I have legacy and modified. And then I can split those two buckets into two further buckets, which is, was it impacted directly or not impacted at all? And so obviously modified, most of the time the code that's been modified has been impacted because I actually touched it. But I could have made some sort of formatting change or something else and really not caused a major impact from a code semantic standpoint. I may not have behaviorally changed that code. So once I have those four buckets, I can look at the code and say, well, the two most interesting are modified and then the legacy code that was directly or directly impacted. I can go one step further and say, well, what about if it wasn't directly impacted, does it contain lines in the code that were also directly impacted? So it's a bit more, somewhat of an indirect impact. When I have that data now, I can focus my team, and this is exactly what we do as we move in our development organizations. I can set a policy that says, I want to test all the new code from March 1st till now. What I'm going to do, though, instead of saying I want 80% coverage, which is typical, I'll say throw away the logging APIs. Throw away the code constructs that I normally wouldn't test, say setters and getters or catch blocks. And what's left is 100%. I should want 100% of what's left. It's going to be a much smaller set. And in the next example, the change set in our front end code, in our most recent release, we did a simple kind of experiment where we created a policy similar to this, and we have 1.3 million lines of code in our analysis in front end code. If you just look, and we're at a very high percentage of coverage. Obviously, we take quality and testing very seriously because of who we are and what we do. And so we're at 83.7% coverage even today. But that leaves, roughly 200-some thousand lines of code untested. So you could say, test that. Well, maybe that's not the right way. If we just look at a small change over a sprint, when we focus on the last set of changes, 851 lines of code were changes over the course of a sprint. Of the code that has been tested, only 145 files were impacted and needed to be tested. So if you go from I need to test to get to 100%, 220,000 lines, well, I don't have the budget or the time to do that. So if I'm going to focus my team, I want to focus them on the 150,000 lines and the 145 files first, and that's a much smaller set, and now it's actionable. And now I'm not overwhelmed and not looking for the path of least resistance to get to my number. Now it's very focused, it's very obvious. Either you did test the latest code and the latest impacted code, or you didn't, right? And work items pop up in front of you as you need them, right? So it's, again, out of necessity of going from manual to automated, we had to use our own technology to pull out the additional data. So now you have 7% of the files and less than 0.2% of all non-covered lines of code that need to be tested to get to a policy that makes sense and allows you to focus. So, this is kind of a marketing slide, but basically we take test coverage, we take static code analysis, and I don't want to turn this into really a sales slide, but the way the technology works underneath is we create a policy, the test advice comes out, and I've kind of covered that, so I'll kind of spare you. Marketing helped me put this together, so forgive me for, I don't want to get too salesy. So if we go into this in a little bit more depth, we have the code, and maybe this is somewhat obvious if I'm boring you to death. The data that we capture through code instrumentation allows us to say whether the lines are covered or not covered. We're basically just covering, using code coverage to do this type of data. What we add in, though, is from the source code repository, the code that has been changed, even who has changed it. We pull that data in from source control management. And so this code we have that's added by, really, Peter Pan? Okay, so they're just trying to kill me here. All right, so, and then the code that was changed, the latest, by David Fast code. Look at that. Wow, they're really trying to hurt me here. So,
How is ownership
well, it depends on how you want to enforce. We have different customers who enforce in different ways. So let's say we create a policy and then a violation pops up, whether it's a defect or a testing violation. A lot of times the automation of the workflow is even as important as finding the issue itself. So we can go into the source control management, assign the defect to the person who last touched the file, and automatically send them an email. So that's where the data for us comes in handy. It actually doesn't matter from a standpoint of, if you're just looking at it from a team standpoint and then assigning the work up appropriately. But we found that customers like to automatically assign it, not necessarily to beat them with the stick and say, oh, come review time, let's see how many violations you've had. It's not like that. It's really more of a...
It's never happened to you guys, right?
Right, yeah. Never been judged by how many defects you've created. What was the joke about, they made I'm going to code myself a new car by entering the contest to fix all my defects, right? So what we found...
For this is you don't need it to do the impact analysis that we do. So when we talk about the algorithms and the secret sauce, it's completely irrelevant. In terms of operationalizing that and turning this from a policy to an enforced policy, it's useful information. That'll become very clear when we look at how we present the data.
Right. So yeah, probably, I think, should we go to the demo at this point?
I would think actually that this is basically a form of slideware. I'd actually let's just show the actual output. I think will be better. So I had a long, fancy presentation that our marketing department helped him put together, so it had nice build slides and PowerPoint and everything else. And it sounds very complicated. In the end, there's one piece of secret sauce here that was not available before. That's what I want to concentrate on for you guys, because this is a technical group, which is basically the idea of new and old code, right? And so the most painful thing you can do, right, and I'm sure everyone has this policy, is tell people test their changes. Who here has ever been told to test your changes? Who's ever been told not to test your changes, right? Exactly. Everyone's been told to test your changes. And if you want to make a group of people in a room feel really uncomfortable, ask them what it means to test your changes. Does that mean the one line that I added, or what if I deleted one line? There's nothing to test, right? So am I done? So if I just, deleting some code, I'm all set, right? What they really mean is don't test your changes. What they mean is everything that was affected by your work, test that whole area to make sure you're not checking any new defects. And if we could all do that, we would be independently wealthy. So the idea is that it gets real uncomfortable because we can't measure that. The secret sauce that Coverity can do is we can put a real date on a line of code based on when that behavior changed of that line, not based on what it changed in revision control. So if you look here in the output that we're showing here, and this data is a little bit old, but you can see here what we can say is, look, this particular line of code changed in revision control on September 13th of 2012. That's a long time ago. But that's not the date that the behavior changed. What we're able to say is here, look here, the actual behavior changed on October 28th. Because we can actually do the impact analysis to say that, it's not the revision control date that matters here. It's when did the behavior change, right? That's kind of the secret thing here that you really want to know. When I made this change, what areas had behavior that changed, and how do I know about that in order to test my changes, which now actually means something. So you can imagine a situation where, here's a better example, right, where this guy, changed over a year ago. So it looks like, okay, this code is really, really old. But in fact, we can say, no, it actually changed this year. We give it a later date. Now, how does that matter? Well, it matters a couple of ways. So one, if I go back to the idea, the number one way we're going to use this information, and I'm going to talk about how we calculate that. But number one is if you go back and tell someone test their changes, we can now say, here are your changes. The way we operationalize that, going back to the question before, as you can imagine, is we put the code into 3 different buckets. So you notice that I have the whole thing annotated here with different colors, right? So the 3 colors are red, green, or gray. So green means I have a test for it. So if I have a test for it, I'm done. So you can imagine a situation in the ideal blue sky world where I make a change, and then I run all the regression tests that I have already, and sure enough, my change is covered by those tests, so I am done, right? That would be your ideal world. You can imagine a situation where I change an area of code for which there are no automated tests, in which case I know I'm going to have to order a lot of pizza. There's also a scenario where you might say, and this is kind of the basic premise, is that everybody has some code that's in production. So if this has been in production for a long time and there's not an automated test, that's the area I'm scared to touch, we can go ahead and say that area is not subject to testing because of its behavioral age, not its revision control age. So the idea would be that as I make a change, we may have lines that are gray that may turn red, right? And if I turn a line from gray to red, I've got to go back and add the test. If the lines are already green, then there's really nothing left to do from an operational standpoint. Is that pretty clear to everybody? I realize there's a lot of us here, but the idea is now I know what my changes are. I make my change, all the dates get shuffled around when I make my change inside of Coverity, and then we go back and we look and we say, based on all these new dates, what additional tests do you have to add? Right? That's kind of the operationalization of it. So the way the algorithm actually works is we can actually tell you why a particular line has its current status. So you can imagine the idea, well, that's great. Somebody made a change. I have to test this why. So the way the algorithm actually works, I don't know if people are familiar with just static analysis algorithms in general. The way the modern ones work is like this. You start with a fully resolved call graph, right? So, with main, and you have every possible, and what you do in that graph is for every function, you have a node in that graph. And whenever there's a call, you have a directed edge between that, right? So you get this large call graph. You'll go crazy thinking of it as a call graph, so imagine it as a call tree. Right now it's nice. I have a root, I have some nice branching, and I have some leaf nodes at the bottom. So the way the analysis works is that we've done for a decade, and this is actually what got the PhDs, is you start with all those leaf nodes and you analyze those methods using a fairly expensive algorithm, right? Approximately of equal difficulty to compiling the code, or maybe slightly harder. Then now that you've analyzed all those leaf nodes, you build up a function summary. So what does that summary say? It says, well, does it dereference its parameters? Does it allocate any new memory? Does it acquire any locks? Et cetera, et cetera, et cetera, right? You have this whole list of the function summary. Now that you have all that information, you can analyze the nodes on top of that, right? And now we know when they make a function call, you know what that function does because you already have the summary on the lower level nodes. So very quickly, you can see that that becomes a depth-first post-order traversal of the call graph. Again, think of it as a call tree. It's a whole lot easier. Dealing with the fact that it's really a graph instead of a tree is the hard part of implementing this, but conceptually, you get the idea. You can work all the way up and analyze everything. So now what we do is we keep track of those summaries over time. So the idea here is that if somebody made a change to this method here, report streaming scan. I don't even know what that method does, but the point is they made that change in such a way that it is externally visible. By externally visible, what we mean is that that function summary has changed. So maybe now it returns new memory that you have to free. Maybe before you could pass it null and it wouldn't crash, or maybe it's something more subtle. Maybe before you could pass it a negative value and that was in the domain. Now you can't do that because suddenly it's not going to behave correctly on negative values, right? You can start to go through all these different possible permutations, but the basic algorithm says that if the function summary changes when I analyze it, then my impact goes up to all the callers, right? All the callers now have to roll forward to today. Then, because the callers have changed, we have to reanalyze those methods. And when those methods, if you reanalyze them and the change causes their summary to be affected, you got to go out further and further. And that's how you calculate the size of the ripple set. I hope that makes sense to everybody, but if it doesn't, the important part is that you have the size of the ripple set to operationalize it. There's some smiling going back and forth like, no way, there's no way we could follow that. That guy's insane. We'll do a more animated example of that if we need to. But now that I have this information, the idea is I could trickle this to a developer. This comes back to the operationalizing question. What are we going to do with this? Well, let's say I write a bunch of new code. I go and run my regression tests. What I want Coverity to tell me is, hey, you made this change and you're missing a test here. You've got to go back and write that test before you can deliver. And I'll go ahead and I'll add tests for that before I deliver my software, right? So there was a gentleman in the beginning who was advertising an opening for a test automation engineer. And the company was very committed to the test automation engineering. Is that what I heard?
That is indeed.
And I'm going to translate very committed means we expect to do a large amount of effort up front, and we expect to amortize the payback over time, so we have to be committed up front. Is that kind of a fair summary? That's a fair summary. And that's kind of one of the challenges of adding a lot of tests is I have to make this big commitment up front. Imagine if we could say to you guys, instead of, hey, you got to do this big investment up front, what you're going to do is bring in the test automation engineer and say, as the developers are working throughout a sprint, the things that they have affected, you're going to automate. You're never going to go back and worry about the old stuff. You're going to do it as the developers write the new software. How does that matter? Well, it matters because it means the things they're automating are the things that most need tested. And chances are that automation is going to pay back in terms of making that a better sprint, with less defects or other things that are going to drag it on, where you're going to get your payback ideally within one sprint, right, or 2 sprints. So now instead of having that upfront commitment with a lot of time, what I'm really doing is coming back and I'm saying, okay, I make a small investment, I get it back right away, I make the next smaller investment, and because my payback is so much faster, right, I don't have to say, trust me when I go to my organization that I want to hire 2 test automation engineers, that we're going to get this benefit a year from now, right? We can actually now bring it back into a time period that saves you a whole lot of work. The other thing we can do with new lines of code, and this is outside of beyond testing, but one of the challenges that we see at Coverity all the time with all of our products is, let's say I go to you as a customer and you've got a big application in production and it works really well today. And let's say I can show you that there's a buffer overflow in that application in code that was written 7 years ago. I realize that doesn't exactly apply to Java, so let's make it a concurrency bug that's been around for 7 years or something else that's been around for a long time. The challenge is if you go to your management and you say, hey, I want to fix this defect because we agree that it's wrong, or this area of code that's ugly, and I want to take this time to fix it, someone's going to say, well, if you fix that, you might break something else. And not only that, but you're going to spend time fixing this that you could be working on new feature development, and our customers pay for new features. So the same guy who's looking for the test automation engineer is smiling, saying, yeah, we get it, right? We're never allowed to fix old defects. We can never get them done. We all know we want to do this work. Now, because we can assign a date, I'm pointing to monitor, that's not going to help, because we can assign a date to every line, you can imagine the ability to go in and say, look, and we can do this to say, remember this old thing in this area that you wanted to fix but you can't justify because you're not touching that area? This code change you just made, it touched that area. So now we can say to the person who made the change, look, you're not responsible for that code being ugly or having a resource leak or whatever else it might be. It's not your fault, but it's your responsibility to clean that piece of code up and add the tests as you did this new piece of work, because the alternative is we're going to deliver something that's in an unknown state, and we don't want to do that, right? So it's very, very clear. Here's this kind of backlog of work items I'm never going to be able to do anything about, and now we can trickle them in based on as we touch areas of code. So that's basically the proposition. I don't have a lot more to say. I'm hoping that I have stimulated enough creative juices that you guys will ask the interesting questions. And there's already a hand, that's my favorite. Give him the watch.
This is great after you've made the change, but we often get asked, what's the impact going to be? If I want you to fix that bug, is it a day, is it a week, is it a month?
Right, and you'd like to know if I change this impact date, is it just right in this area, or is it going to propagate out to 17% of my code?
Can I pick a function and say, if I mess with this, what happens?
So we have another component that I haven't talked about, yes, for that purpose, right? We call it architectural analysis. The architectural analysis is not going to put as tight of a bound on it as the after the fact. What's going to happen in architectural analysis is you're going to say, show me the closure of the impacted code, meaning this is the maximum possible set. Right, that gives you an estimate up front, right? A worst case estimate. Then you're going to make the change, and we're going to do the calculation afterward and say, here's what your actual was. So, right, because obviously we can't measure perfectly going in, but at least you can get some idea of, right, do I expect this to be a day or a month, right? And you can narrow it down, but that's exactly it. Right, and of course the other thing though is once you've made the change itself, we can now say, look, here's how many more tests you have to add. Most of the time when these are a day or a month, what happens is you make the change in a day, and tell me if I'm wrong here, right? Or 2, is the question is how long is the test effort? Right, so once you've made that change, we can do an exact calculation, and now we can say, look, there are 2,200 lines that have no tests, that now as a result of, but where before we said, oh, they're in production, they're so old, they're reliable, they're not on our radar, we got to go back and add that, so the test automation engineer can come back and say, okay, well, I think it's going to be 2 weeks to add all those tests. Right, but again, the idea is that once you made the code change, you can get a very, very accurate estimate on the testing level. So if I could give you the prize for asking, the first question, I would.
A follow-up on that, though. So another thing we have with test automation engineers is the first 2 days of the sprint, they're not sitting on their hands, because they'll hit me for saying that, but they're not also really writing something. If they wanted to go and say, I'm going to pick an old piece of code, how many tests would I have to write to automate this function? You follow the question?
Yeah, I follow the question, right. Yeah, I mean, it's not something we're really addressing, but I follow the question. The idea is you want to say, look, I've got this idle time. What should I go after next?
Or I know what to go after next, but I don't know if it's going to be an hour to write a test, or is this suddenly going to ripple all the way up the tree and I've got 400 tests I got to write?
Uh-oh, something bad happened here. Oh, there we go. So one of the things that we can do that will help, and this is not a good example because the tests aren't separated, one of the things we didn't talk about is that assuming you're using one of the many test coverage tools that we know, or the testing frameworks that we know about, like JUnit or things like that, we can actually do what we call test separation. So the idea of test separation is if you look at a code coverage output, right, it's typically red and green. Yes, you tested this. No, you didn't. Yes, you did. No, you didn't. One of the value adds that we can put in, and again, this is on the operationalization side, that's a hard word to say, is that we can tell you what test covered what line of code and how many tests covered that line. And the reason that would matter is you could imagine if I had this piece that I want to test that I don't know much about, or an old one, I could come back and I could say, well, what test could I extend? That's not a perfect metric, but at least it would say, okay, if I want to go after this area, or maybe I'm not familiar with this area, or whatever else the case may be, what tests are there? I'm going to use that as my starting point and extend that test. That doesn't actually say what the effort is. Admittedly, you can almost calculate the testing effort for a particular area of code because you can just count the complexity using like CCM. We'll just look at the number of branches. If it's straight linear, it's one test, right? If you have 10 branches, it's going to be, right, you're going to have at least 10 tests if you want statement coverage, right? More if you want branch coverage. Again, it's not a perfect answer, but it's the best one I have. Yep.
So this works really well when you're writing unit tests. What if you're writing your tests at a higher level? What if you're using, for example, behavior-driven development, where your tests are expressed in terms of business logic, user functionality, completely divorced from implementation details? Can you tie code coverage back to the statement of business logic?
Right, and so the answer is usually, and I hate to give you that answer, but so here's what happens is what we do is we have a test separation API, meaning you say through an API, this test is starting, this test is ending, this test is starting, this test is ending, and that's completely user accessible. Now, if you're using a testing framework or tool with which we have a pre-built integration, that API gets called automatically, and you get the test separation for free. So, for example, with JUnit, right, you just check a box that says I'm using JUnit, we know about it, we do the test separation. If you have a custom testing framework, right, or a custom testing tool, all you've really got to do is be able to tell us, here's where my test starts, here's where my test stops, and then we can tie it back to that test. That integration should be easy, right, in most cases, assuming that the tool, the tool has some way to integrate with it, right? It's pretty easy to figure it out. Now, even if you don't have the test separation, right, you still get a yes or no. But if you have that type of very, very expressive testing, you'll be happier if you can say what test covered this, right? The other thing you may start looking at as well, which I really didn't want to talk about today, but is test elimination. You might say this test is redundant, right? It covers the same thing as this other larger test, or vice versa, right? Or you have this one large test, but all of it's covered by these two simpler tests. I'd rather keep the two simple tests, right? But again, that's kind of a secondary thing. The main goal would be that you would know what test covers it, so you would say, okay, and what's not covered, so you would say, okay, how do I, and then of course you'd have a little bit more work. So a unit test writer has an easy time once he has the data, because he just says, okay, I got to exercise these lines of code with a JUnit, where you're going to have to go back and say, okay, what behavior do I have to express to cover this area? But you still have the same data, right? And presumably the guys who are writing that are conversant in terms of they would have a pretty good idea what to do.
Do you have a mapping of, what test manual, automated or unit map back to a business requirement?
Well, when you're using behavior-driven development, your business requirement is expressed in a formal language that looks like English, and it is self-validating. It's like an assertion. You implement code underneath it that ties it into your system under test, and it's like you're making assertions in Java.
Right. When you're doing that, typically you're using much more formal processes. Are you using that along with like some tools as well to like ALM types? What's that? Cucumber, right? Yeah. So you guys are obviously very formalized, right? Express the requirement in a formal, using a formal method, and I can follow it all the way through, right? And depending on what those tools are, like Cucumber, the nice thing is if we find one of these issues, sometimes we can tie it back to the new requirement, right? If you really do a tight integration, right? We could tie it all the way back. Because again, Coverity, we talked about testing tonight because we're not here to pitch our product suite, but obviously if we could also say, look, in the development of this requirement, you introduce a resource leak. This is why it has to be fixed, right? A lot of people like that traceability. But you could also see when I introduced this requirement, it required me to add these 4 new tests, right? You may want to have that traceability all the way. That's obviously a longer discussion, but the short answer is that it's feasible.
Can you combine the analysis at different levels? For example, when the developers are writing the code, they may write, we hope they write unit tests, and then when they integrate their code with some of the modules that surround it, with which it interacts, they have some integration tests.
Right.
And then when you get it to a larger system, you have some end-to-end tests. Can you then show these are the functions that you haven't tested over the entire thing?
Yeah, and the answer is yes, because again, we don't care how you write the test. All we care is you call the test separation API. And you could run test 100.
Running the test at separate times, different times.
Yeah, that's okay. The infrastructure's all there to do that, right? Yeah, you can take all that data and pull it forward. It's been done. So yes. So I'm not repeating the questions. I hope that's okay because I think. All right, what the heck? We got
2.
You
guys
two.
You have a plugin for fitness?
Do we have a plugin for fitness? No. That doesn't mean we can't integrate with fitness, but there's not an out-of-the-box plugin.
Okay. So a question. It sounds like you know at a check-in time which tests would have to be run.
Yes.
Do you have the ability to go to the JUnit framework and say, don't execute everything? So I'm thinking of the continuous integration where every time we check in, we wait 5 minutes, we batch them all together, we blow off the 15 minutes of automated tests, and if it turns out I really only needed 1, that's 15 minutes of the resources, frankly, wasted.
Right.
Do you have the ability to say, JUnit, hey, don't do all those other?
Yes, so we have what we call test prioritization, which is what you're really asking about. So we can say for this particular set of deltas, look, here are the tests that you really, really need to run. Running these other ones are low value. We're not ready to say you don't have to run them. We're simply going to say that from a probabilistic standpoint, if you run this set, you're probably going to find everything. These ones are probably redundant. So what we recommend you do, of course, is at minimum is prioritize them in that order, and how long you choose to run is your own thing to figure out. For real life, meaning pre-QA, right? I don't want to run all of them, but certainly for every check-in, it's reasonable. We have a lot of customers who say, give me the 5 minutes. I want to limit it to 5 minutes, right? So only run the stuff, the 5 most valuable minutes, right? And then I'm done. That's the cutoff.
And the evaluation that your tool does tells what those most important tests are, or what that set of tests is?
It does, and the way it does that is that it basically determines, because again, we know the test coverage, so we know what lines were impacted, right? We know the impacts out of that change. So you might have 1 million lines of code, and you might have 400 of them impacted by that 2-line change. So we're just going to go back and do a straight lookup. What tests hit those 400 lines of code that were impacted? Those are the ones you need to run. And then we can prioritize them further based on maybe run the most complex first or the least complex or whatever your next set of rules are, right? But I mean, the easy buckets are yes or no based on did the test actually hit an area that was affected by the change. Because if they don't hit an area that was affected by the change, then they're going to be very, very low value. Yep. But
His question correctly, he was asking, can you do that without human intervention?
yes. Because we generate basically a piece of data that can be understood, right? There's a few rough edges, but the point is we generate the list. Here's a list of tests you need to run for JUnit.
But can you kick that back into JUnit? So Hudson runs, does your build, does the analysis, then you output some stuff for JUnit, and you tell JUnit, only run these tests.
Right, that's essentially it. There are a couple of details. I don't know how that works. One thing is you run the tests under our, we have our own capture, we have something called the capture utility that handles most of that. But yes, that's the idea. That's exactly what that's used for. Because again, if a human had to go manually do that every time, it really wouldn't be valuable, right? The whole idea is to say, again, we have customers who have regression suites who are 12 hours.
Yeah, that's our overnight. We struggle with, you spend so much time doing the automated builds throughout the day of the check-ins that you get behind. And the engineers get frustrated, and they go off for coffee that turns into pizza, that turns into, they come back an hour later. And if it had only been 2 or 3 tests that really needed to be run.
Right, so what you can do for every check-in is you can say, look, we're going to do an incremental build, and then we're going to say we're going to run 10 minutes of tests. That's the maximum you get, right? Do that 10 minutes. And if it doesn't come in at 10 minutes, doesn't mean you don't run them. You can run them on the next check-in. because they'll get reprioritized on the next check-in based on the impact dates, right? So you can actually deal with that by maybe they'll get picked up the next check-in. And that's going to be a very long customer-specific discussion, but the idea would be that you could limit yourself to some fixed amount of time per check-in to guarantee that you get the test run, you have the binaries, and you're ready to analyze the next check-in. Let's go. Is this a question back here, sir? Because I feel like, we're going to try to get to people who haven't asked any yet, if that's okay.
So two questions. Who's the target user within an organization that would be using this product? And then second, what's the ramp up on the learning curve? Because it sounds like it's got a lot of really great features, but it seems like it wouldn't be friendly to maybe a developer that would spend most of his time developing code. It might be someone more on QA testing.
Right. So the first question, who is it targeted for? Our original target when we developed the product were testers who were embedded in the development organization. That goes back to the original thing because we originally developed it for ourselves, and that's who benefited, right? So that was clearly the testers who were embedded in development were the ones we were going after, right? And so, which in some cases are the developers, right? Like if you're very TDD, they're the same people. Sometimes they're not, but that was our clear target audience. What's happened, of course, is we get questions like we got over here. Well, what about the tests that QA runs? I want them to do the same thing, especially if you think of test prioritization for QA, because if you prioritize your 12 hours of test overnight, that's great. You got it down to 1 hour, right? Imagine a QA tester who's spending 2 weeks, who might be doing things in a terrible order, right? You can imagine saying, well, if I can make that QA tester more efficient, I save all this wall time. Right, so that certainly the use pool has expanded, right, to anybody who's doing tests, manual or automated at this point. As far as the learning curve, right, I mean, as far as knowing everything that happens under the covers, that may take some time. We have a wizard to get started. People who do evaluations, we tell them it should take about an hour to go start to finish to get a set of results that they can understand. Because again, remember, if you're a developer and a user of this, right, not a super user, and you get a message that says, hey, look, you got to write a test that covers line 64, right? I mean, that's an easy thing to do, right? Assuming you know how to write the test. If you're the right person, as long as we direct that to the right person, says, hey, you're the guy who's responsible, this test is needed, right? I'm assuming that the person can actually write the test. Is that a fair answer to your question? Okay.
Have you seen any data in the field on lower amount of time testing versus increased reduction in defects found?
Yeah, we have lots of, at least anecdotal data from our customers, right? Who said, look, this is how much time we estimate that we have saved, right? We have our own internal estimates as well, but those are less interesting than the ones where the customers came back and said, I saved this or I saved that. So yeah, I don't have all those numbers, but our marketing department loves to collect that data. So if you want nice colored glossy PDFs, we got them.
I guess my question, I'm struggling to see how, I created an automated test using something like Selenium.
Right.
To test the server and the client-side code together, integrated. So I'm struggling to see how you would link that back to lines of code, that when you do the log on, how do I know what lines of code were impacted by that client-side in a browser, automated test?
Right, so what you do to deal with that, to get the lines that are actually covered by the test, we just use open source coverage tools. So the most common ones are like Emma, Jacoco, what are the other ones? Covertura, OpenCover. I thought OpenCover was .NET. Oh, okay, right, sure. Right, so they're for .NET. Oh, there's some .NET people here, sure. So basically the coverage tools will already tell you. The coverage tools are basically free to cheap, right? That'll tell you yes or no, this line was covered or not. So you have to have the coverage tool running on your server, right? The browser hits it, and the server says, okay, you just hit these lines. What we're doing on top of that is we have the test separation API where Selenium would say, I'm about to run this test. And then we would say, okay, the coverage tool just said you hit those lines. Then Selenium will say, I'm done running that test. And now we can say, okay, not just that you hit those lines, but we know what test did it. If you can't get test separation, we're still going to tell you those lines are tested or not, right? So there's still value there because after all, if you look at the simple example where we're coming back and saying, hey, you don't have a test for this and you need one, right? That's like the simplest use cases. We don't care what test hit it or not, right? Or no test hit it. We don't care. It doesn't really matter what test hit the surrounding lines. You just need to know that, right, if you ship this way, you're shipping an unknown. But if you can know the surrounding test and what's covering it, that's often very valuable, especially if I'm going to go back to Selenium, because then I can say, oh, well, this test hit this guy, but the issue is here, right? There's a check. If stream status not equals null, do this. You can see very easily, oh, okay, I got to write another test that's almost identical to this one, but that triggers the other branch of that condition, right? That's just really all the other the impact dates, right? And are the secret sauce. The policy that says what you have to test to turn things red is step one to getting going. Everything else is about operationalizing it in a way that, to the question earlier, the developers who are using it don't have to know a lot about Coverity, right? Or the testers who are using it don't have to know about Coverity. They just have to know, look, you got to hit this line, or we haven't made our policy, we can't accept this, right? We're not going to waste time, putting this out in the field or putting it over for formal QA because there's this whole unknown entity. Should we go? Sure, go right ahead.
So with a very old legacy code base,
Right.
we find that a impact at a low level, we're not sure where it all bubbles up.
Right.
Sounds like you guys are able to build those inverse graphs.
Right. That's exactly it.
Are you able to call it back to, say, a servlet level, to say a call to this servlet, or a call with these parameters?
Well, because remember what we're saying is you change this piece of code. Here are all the areas you could affect. Now, how I would actually affect those areas, right? Meaning what test cases would cover them. Say, oh, well, so your question, I think if I understand your question, it's, look, I had this untested area, I made a change that affected, but I have no idea how to even start, because I have no way to reach that code. I don't know how to reach that code, so I'm in big trouble because how can I possibly test that? And the answer is we really don't have a good way to do that, right? But we see the problem. One thing we can do for a lot of applications is we can enumerate the endpoints to give you a starting, but that may not help. One thing we do, however, have that will help you put things in a bucket is we have something called reachability. So reachability is actually something I wish we talked about more, but the idea of reachability is this. Let's say I have a test suite today, right? And I cover 60% of my code, right? Well, if I'm covering the most important 60%, that's really good. If I'm covering the least important 60%, that's really bad. But let's say I want to get to 80%, right, or something else. One of the challenges might be that there might be some code that I just can't reach at all. So the idea of coverability goes back to the call graph, and it says, here are all the lines that you covered by your tests today. If those tests were more sophisticated, given the set of entry points that we have now found based on your tests, what areas could we get to? We might identify, look, for your current test, there's this whole swath of code that you can just never test by extending them, because you need a new endpoint to get to that code. Right, so we can basically say, for the set of endpoints that you have today, or you've exercised in your test, can you get there or not? And if something is in it, oh well, we don't, no endpoint can get there, your answer might be to delete it, right? The way to test that code might be to delete it. Yep.
If your test code base uses something like Spring, Spring for example, or automated test code uses Spring to inject objects and whatnot, can it actually follow those through and also see that those are the services that are being called in order to test the system under test?
Right, so remember, the answer is yes, but remember two things. Remember, because the coverage tool is just saying what lines are there, and it doesn't care how you got there. And the test separation API is just saying what test is this, right? So we don't really care if you're using hamster wheels to generate those tests, right? The thing we do care about Spring a lot of times, the biggest thing we care about in Spring is not related to the testing. The biggest thing we care about in Spring is making sure we understand all the endpoints so that we can basically figure out, whether this is reachable or not. Right, but it doesn't really matter, right? Because you can imagine, again, we could do this with a manual test. You could do a browser-based test where you have a form that fills and says, I'm going to write test ABC, and I'm going to hit the login button. We don't recommend that you do your testing that way, but if that's where you're at today, right, you could do it. Yeah. Yep.
A little bit more following that train of thought, the limitations of this product on the technology platform that's being used. For instance, if you have JNDI or EJB beans that are being kind of shuffled through in your architecture, and it might have some trouble looking up at the endpoints, would that be a type of limitation that?
Well, so that would be a limitation for us in terms of ability to enumerate endpoints, right? That's true, but remember, you have a set of test cases, and the coverage tool does not know what that Java code does. It only knows, did you run that line or did you not? Right, so in the end, for every line of code that was built, so one of the things that does matter, by the way, we have something called the build capture agent, which we use for all of our stuff. The basic idea of the build capture agent is to use the Java profiling API to watch for compilations. So we don't care if you build with Maven or Ant or everything else. We can get an accurate bill of materials that says, here are all the things that were compiled. Here's all the Java code that goes into your application, right? Then the coverage tool runs, and the coverage tool says, here are all the lines that were tested, right? And again, we may not be able to some point say, for example, we're not doing request dying. I think that's the challenge here, right? You could imagine a request dying situation where there's a network hop call or an EJB call where it calls back through local where If I'm trying to debug through that with some sort of debugging type tool, I may not be able to see where that endpoint goes. But because the coverage tools aren't doing that, they're interfacing at the JVM level, and they're saying, tell me what lines get hit starting now. And any line that gets hit, the JVM reports it out. Again, it doesn't really care what the code does. That's kind of the difference between what we're doing with the test separation API versus if you guys have used tools that do request dying to try to follow things across multiple tiers. That's a completely different discussion, right? Because we're not tying the tiers together ourselves. We're simply saying we have coverage on these different tiers. What lines just got hit? What tests are we in, right? And we have no idea how the request got from one to another. We're not trying to follow it directly, right? It's an indirect measurement. So does that make sense? All right. So anyone who has not asked a question who wants to get one in, because I feel like we have a very aggressive group, which is good. We appreciate it, but I don't want anyone to feel locked out. So I'll ask you, are there any important parts of the thing that what we're doing that I missed? No. Nope. Okay.
That's why I let you start talking.
That's why you let me start talking? All right. So by the way, I hope you still have the job for the test automation engineer. I hope I didn't just dash somebody's hopes. You still have it. All right. You now have a better thing to give them to do day one.
That pretty much sums up what we have, unless there's any additional questions. Obviously, we can do demos and free trials of our code, just to give a little plug right at the end. So hopefully it wasn't too salesy. Did you find the topic and the discussion interesting? It seemed like it was good topic, good discussion. I appreciate you all coming out.
Could we do a survey in terms of the technical level, were we too high or too low, so we know for next time?
Yeah, did we hit the mark in terms of, it's a very technical crowd, did we hit the mark and keep it technical?
Yeah, so technical
Yes.
levels, okay, too high, let's do too high, okay, or too low, right? Too high, too many technical details, put you to sleep.
Too low, we bored you to death? About right for typical?
All right, we'll take about
All right, yeah, that's good. Thank you.
The only feedback I did is on some of the charts. I was interested to understand what was the X and Y axis. I wasn't able to see under that.
Oh, I apologize. I think we can provide the set of slides to you so you can look at them deeper. They should be labeled, and if not, my email's in them so you can ask. Good feedback.
If you just email me the slides, I can upload them either tonight or tomorrow morning.
Sure. That sounds great. Okay, thank you for that feedback.
There's only one other thing that I would add. I would love to see a very small kind of a Word app demo sort of thing. If it's possible, again, I know configuration doesn't matter.
Sure. Typically, it requires that we build, we analyze, we run the test, then we show. We could.
We have a canned demo Hello World, right? So you can actually go through.
Right, but no. What he's saying is that we should have had a live. Like here's an application. Build it, analyze it, run some tests. Show before you run. Should run a test. Show afterwards. Maybe create a test and cover that and see how it reacts. We can certainly add that in. What's that? No, not at all. I mean, I've done it sitting with customers on their code, or even run full demos myself. So Ed and I have both done it. So We've been with the company 7 years, and I started again in a technical. So that would have, we could have added that.
After the presentation's done, we can fire up somebody's laptop and do it if you want. It's actually pretty easy to do.
Right, so. But thank you, that's good feedback. That's it.